In this lesson, we will finish our solution to the Pollyanna problem and then solve another problem using several different strategies. In the Pollyanna problem, a husband and wife are driving to her mother's house. They have an appointment with a marriage counselor en route. After some time passes, the wife asks, "How far are we from our house?" The husband replies, "Half as far as from here to Pollyanna's office." While after the appointment, they are 200 miles from where the wife asked her first question. She now asks the second question, "How far are we from mother's house?" The husband takes advantage of this golden opportunity and responds, "I told you already, half as far as from here to Pollyanna's office." How far apart are the two houses? In the diagram we used for our first solution, Pollyanna's office was placed exactly halfway between their house and mother's house, which made the solution easier. It's probably not true, though, that it would be exactly halfway. In this case, I have placed it a little bit to the left, closer to their house. The 200 miles in the middle is made up of two smaller sections and two larger sections. If two small sections and two large sections equal 200 miles, then one small section and one large section would be 100 miles. The extra part before and after the questions are another small part and large part, which would be an additional 100 miles. So the total distance between the houses would be 300 miles. This was the answer we got with the simpler diagram. It makes sense that if this problem only has one answer, it shouldn't matter where Pollyanna's office is. So the previous problem, which was the simplest case, did give us the correct answer. That reasoning can be made more formal using algebra. We define the variable x to be the distance from their house to where the first question was asked, and y be the distance from where the second question was asked to her mother's house. Then the 200 miles between where the questions are asked consists of two x's and two y's, so we have the equation 2x plus 2y equals 200. Dividing through by 2 would give us x plus y equals 100. That's the distance before the first question and after the last question put together. That additional 100 miles added to the 200 miles in the middle gives us 300 miles. Or the whole distance is 3x plus 3y equals 300 in this case. In this problem, there are ducks and rabbits in the yard. Together they have 12 heads and 30 legs. How many of the animals are ducks and how many are rabbits? We're going to solve this problem using Pollyanna's 4-step procedure. First step is to understand the problem. What do we know? We're given that there are 12 heads and 30 legs. To solve this problem, there's additional information that students may not have. So before presenting this with the class, before having them solve it, we want to discuss what a duck looks like, what a rabbit looks like. A duck has one head and two legs, while a rabbit has one head and four legs. Another part of understanding the problem is understanding what it's asking for. It's asking how many ducks are there and how many rabbits are there. Pollyanna's second step is to devise a plan. This often involves choosing a problem-solving strategy. For this problem, one strategy that can be used is guess and check. This strategy is useful when there are one or more unknown quantities, along with a means of testing whether a given set of values is correct. We can guess how many ducks and how many rabbits, and check to see if that answer is correct. Pollyanna's third step is to carry out the plan. When executing a guess and check strategy, it's useful to set up a table of the guesses and our checks and evaluation of these. Students often have difficulty or reluctance to guess because they don't want to give the wrong answer. A problem-solving teacher I used to work with said, when in doubt, guess 5. So if we start with a guess of 5 ducks, since we know there are a total of 12 animals, there would be 12 minus 5 or 7 rabbits. Since each duck has 2 legs and each rabbit has 4 legs, there would be 2 times 5 or 10 legs for the 5 ducks, plus 4 times 7 or 28 legs for the 7 rabbits, for a total of 38 legs. In guess and check, we need to have a target. We know that there are supposed to be 30 legs. 38 is greater than 30. That's too high. So since rabbits have more legs than ducks, we really need fewer rabbits or more ducks. So our next guess should have a larger number of ducks. If we guess 10 ducks, for a total of 12 animals, there would be only 2 rabbits. The number of legs would be 2 times 10 or 20 legs for the 10 ducks, plus 4 times 2 or 8 legs for the 2 rabbits, for a total of 28 legs. This is too low. It's less than our target of 30. So we need more legs, which would mean more rabbits and fewer ducks. Also, since 28 is pretty close to our target of 30, we don't want to go much lower. So if we guess 9 ducks, that would leave 3 rabbits for a total of 12 animals. The number of legs would be 2 times 9 or 18 for the 9 ducks, plus 4 times 3 or 12 for the 3 rabbits, for a total of 30. This is what our target is, so this would be the solution. There are 9 ducks and 3 rabbits. Polya's 4th step is to look back. Part of looking back is seeing if we can solve that problem using other methods. For many problems which we solve using guess and check, we can also solve them more directly using algebra. For algebra, often the hard part is coming up with an appropriate equation that corresponds to the problem. The guess and check table is a way of setting up the equation, seeing what the relationships are in a problem like this. Suppose we let our variable x be what we were guessing, the number of ducks. Once we knew the number of ducks, we determined the number of rabbits by subtracting the number of ducks from 12, since we were told 12 animals. So if x is the number of ducks, the number of rabbits is 12 minus x. To find the total number of legs, we multiplied the number of ducks by 2 and the number of rabbits by 4 and added those. So if there are x ducks, there'd be 2x legs for them. If there are 12 minus x rabbits, there'd be 4 times 12 minus x legs for them. So the total number of legs would be 2x plus 4 times quantity 12 minus x. When we use algebra, we solve an equation to find the unknown. The equation has an equal sign, so we need to set the number of legs equal to some amount. In a guess and check problem, that would correspond to our target. There's supposed to be a total of 30 legs, so our equation would be 2x plus 4 times 12 minus x equals 30. We distribute the 4 times 12 is 48, 4 times negative x is negative 4x, so we have 2x plus 48 minus 4x equals 30. Collecting like terms, 2x minus 4x is a negative 2x. Subtracting 48 from each side gives us negative 2x equals negative 18. And dividing each side by 2 gives us x equals 9. This means there are 9 ducks, and the number of rabbits is 12 minus x, which is 12 minus 9, or 3. Since this problem was asking for 2 quantities, how many ducks and how many rabbits, we could also solve this algebraically using 2 variables. If we let x equal the number of ducks and y equal the number of rabbits, then since there are 12 heads, x plus y must equal 12. Also, we saw that the number of legs should be 30, with 2 legs for each duck and 4 legs for each rabbit. That gives us the second equation, 2x plus 4y equals 30. In the 4th unit, we will review methods for solving systems of linear equations and 2 unknowns. 2 common methods are elimination and substitution. We'll use the elimination method here. We want to eliminate the x variable. We have 2x in the second equation. If we could add negative 2x to it, x would be eliminated. We can get a negative 2x in the first equation by multiplying the first equation by a negative 2, which gives us negative 2x minus 2y equals a negative 24. Adding that to the second equation, 2x plus 4y equals 30. The negative 2x and the 2x will cancel. Negative 2y plus 4y is 2y. Negative 24 plus 30 is 6. So we have the equation 2y equals 6. Dividing both sides of the equation by 2 gives us y equals 6 divided by 2, or 3. To find x, the first equation is x plus y equals 12. We substitute the value y equals 3 into that first equation, which gives us x plus 3 equals 12. So x would be 12 minus 3, or 9. Thus, there are 9 ducks and 3 rabbits. We can also solve this problem by drawing a diagram. Rather than drawing more elaborate ducks and rabbits, I'll use a simple diagram with an oval for a head and a bar for a leg. We have 12 heads, so I'd first draw in 12 ovals. Each head has at least 2 legs, so I draw 2 legs on each of those 12 heads. So that's 24 legs we know, at least, are in this problem. There should be a total of 30 legs, so we need the difference, 30 minus 24, or 6 more legs. Since each rabbit has 2 more legs than a duck, I would need to put 2 more legs on 3 of those heads. So there are 3 rabbits, and the remaining 9 animals are ducks. In the activity today, there's a similar problem involving bicycles and tricycles, which can be solved using these same methods: guess and check, algebra with 1 variable or 2 variables, or a diagram like this.